In this video, we'll be graphing exponential functions. Let's graph each exponential function, state the domain and range in interval notation, and identify any asymptotes. Our first function, f of x, is equal to 2 to the x. Well, when we first learn a new function, our graphing technique is to make an xy chart and then plot points. That's what we're going to do for all of these exponential functions. We know that the domain is all real numbers. So when choosing x values, we want to choose some negative, 0, and some positive. I recommend always choosing the x values -1, 0, 1, and 2. Exponential functions grow very rapidly, so you don't want too big of an x value or your graph is quickly going to go right off the paper. So let's find our corresponding y values. If we plug -1 in for x, that's 2 to the -1st power, which is 1/2. Plugging 0 in, 2 to the 0 power is 1. Plugging 1 in, 2 to the 1st is 2. And lastly, we have 2 to the 2nd, which is 4. So here are our 4 ordered pairs that we're going to plot. -1, 1/2, 0, 1, 1, 2, and 2, 4. All of our exponential functions have a horizontal asymptote on the y-axis. We'll draw that in. We know that these 4 points are going to connect, and we also know that one of the ends of our graph has to tend towards that horizontal asymptote. So which end do you think it's going to be? Well, the end on the left that's already really close to the asymptote. So this is going to continue extending, getting closer and closer to the x-axis, and the right end is going to continue up. So there is the graph of f of x equals 2 to the x. We want to state the domain, the range, and the equation of any asymptotes. The domain of all of our rational functions is -infinity to +infinity. We can also see that from our graph as we have an arrow pointing to the left and an arrow pointing to the right. The range, since we have that horizontal asymptote, our y values don't start until we're on the positive side of 0 and then extend to +infinity. Lastly, we want to identify the asymptote. We have a horizontal asymptote on the y-axis. So we say that we have a horizontal asymptote at y equals 0. Try another one. Let's graph f of x equals e to the x. Again, we're going to create an xy chart to get 4 points. Again, we're going to choose x values of -1, 0, 1, and 2. We'll plug these x values in and get our corresponding y value. Now, this is not one that we're going to be able to just do in our head. We definitely need our calculator for this. So you're going to be looking on your calculator for a button that says e to the x. Some calculators you have to put the x value in first and then the e to the x, and then other calculators you put the e to the x in first and then put in the exponent. So finding e to the -1st power, we're going to get 0.37. E raised to the 0 power will be 1. E to the 1st, 2.72. And then lastly, e squared 7.39. Those are the 4 points that we are going to graph for f of x equals e to the x. Now we're just going to have to estimate when plotting these points since we have a bunch of decimals. So that's negative 1.37, 0, 1, 1, 2.73, and 2, 7.39. We know that there's a horizontal asymptote on the y-axis. And we also know that one end of our graph is going to have to tend towards that horizontal asymptote, and it's going to be the end that's already really close to the horizontal asymptote. Here's the graph of f of x equals e to the x. Please notice that this graph is a little steeper than the previous one. With e to the x, e is 2.72, so we have a larger base number in this example than the previous example. The larger the base is, the faster the graph grows. It's going to be steeper. Let's graph one more. You'll see that this equation has more to it. This is an exponential function that has transformations. Basically, all of our new exponential functions are a bunch of new parent functions that we can then graph by transformation. So let's graph each exponential function by transformation. We'll state the domain and range in interval notation, as well as identifying any asymptotes. Like anything that I graph by transformation, I like to start by outlining my plan. The first thing is going to be our parent function. The parent function is going to be an exponential function, some number raised to the x power. Our base in this example is 3, so our parent function is going to be 3 to the x. Something you need to note, since we're graphing by transformation, the exponent is considered the inside of the function. So you may want to put parentheses around it just to reinforce to yourself that that's the inside function. And now we start looking for our transformations in order. We always start with the inside of the function. There's only one thing happening inside our function other than the x, and that's a negative. Multiplication by negative on the inside of a function tells us that there's going to be a reflection about the y-axis. And when reflecting about the y-axis, we always multiply our x values by -1. Then we move outside the function and start looking for transformations. Now note, the 3 is part of the parent function. That is not a vertical expansion. That is part of the parent function. If there was a vertical expansion, you'd have to have something like 2 times 3 to the -x plus 1. It would have to be really obvious with parentheses around the 3 to the x or a multiplication dot as I've written it. So that 3, part of the parent function, not a transformation. The only other transformation we have is that +1 on the outside. And we know that +1 on the outside tells us that we need to shift our graph up 1. All right, let's get some points for our parent function. We're going to do so by making an XY chart. We're going to use the x values of -1, 0, 1, and 2 again. 3 to the negative first, that's 1/3. 3 to the 0 is 1. 3 to the first is 3. And 3 squared is 9. So those are the points for our parent function. Let's plot them. Remember that all of our parent exponential functions have a horizontal asymptote on the y-axis. And we'll plot our points. -1, 1/3, 0, 1, 1, 3, and 2, 9. And the end closest to our horizontal asymptote is going to tend towards that horizontal asymptote. There we go. There's the graph of f of x equals 3 to the x. We're ready for our first transformation. We're going to be reflecting about the y-axis. To get the points for this second graph, we're going to multiply all our green x values by -1. So that'll give us the points 1, 1/3, 0, 1, -1, 3, and -2, 9. Before I plot these points, I want to talk about what happens to our horizontal asymptote when we have a reflection about the y-axis. Does that asymptote move? Well, when reflecting about the y-axis, everything on the left side moves to the right, and everything on the right side moves to the left. So this left side of our horizontal asymptote is just going to flip over and be on the right side. Similarly, the right side of our horizontal asymptote is going to flip over and become the left side of the horizontal asymptote. The horizontal asymptote stays in the same spot. It's just kind of, flip-flopping on itself. Asymptotes staying put. Let's plot those new points. 1, 1/3, 0, 1, -1, 3, and -2, 9. And there's our red graph. One more transformation to go. We need to take the red graph and shift it up 1 unit. To get the correct points for our final graph, we are going to be adding 1 to all the y values. So we'll have 1, 1 1/3, 0, 2, -1, 4, and -2, 10. Before plotting these points, let's talk again about our horizontal asymptote. If I'm shifting my whole graph up 1 unit, does the horizontal asymptote move too? That horizontal asymptote is a guideline for our graph. It tells us kind of where we need to stop. So yes, it does need to shift up 1 as well. If not, we would end up having extra space between our points and the horizontal asymptote. So our asymptote will shift up 1 unit as well. And then we'll plot our points. 1, 1 1/3, 0, 2, -1, 4, and -2, 10. And here we have our final answer in blue. The graph of f of x equals 3 to the -x plus 1. We need to state the domain and the range, as well as the equation of our horizontal asymptote. So let's start with the domain. The domain of all exponential functions, no matter whether we have transformation involved or not, is negative infinity to positive infinity. And we can see that from our graph as we have an arrow pointing to the left as well as the right with no breaks in the middle. The range, well, since we have a horizontal asymptote and our graph is only above that horizontal asymptote, our range starts on the other side of positive 1 and goes to positive infinity. Lastly, we want to state the equation of our horizontal asymptote. Remember that it shifted up 1, so now it's up here. So instead of being at y equals 0, it's now at y equals 1.